Suppose that the temperature on a unit sphere is given by T equals 20 x, y, z squared in Celsius. So here are the level surfaces of that temperature function. You can try adjusting. And let's find the points of highest, maybe a more familiar way to say this is to find the hottest and coldest points on the sphere. So our first step is to, so we're trying to optimize the function t equals 20xyz squared subject to the constraint of being on the unit sphere. So x squared plus y squared plus z squared minus 1 has to be equal to 0. Okay, so the first step is finding the gradients. So gradient of t is 20yz squared I plus 20xz squared j plus 40xyz k. And nabla g is 2xi plus 2yj plus 2zk. So, and then our equation for Lagrange multipliers is nabla t is lambda nabla of g. So this expands to the system of equations 20yz squared equals 2x lambda, 20xz squared equals 2y lambda, and 40xyz equals 2z lambda. So to solve this, let's start with the last equation. So we'll cancel a z from both sides. So actually we may as well assume that x, y, and z are all non-zero because t of, if any of these were 0, then otherwise, then t would be equal to 0, and we can see easily that there's points of higher temperature and of lower temperature than 0. Okay, so if we do this, then we get that that lambda is equal to 20xy. So then putting that into these equations, 20xy, 20xy, then we can cancel these 20s. We can, right, since these are assumed not to be 0, we can cancel the y here. We can cancel the x here. So we are left with z squared equals 2x squared, and and z squared is also equal to 2y squared. So in particular, these two are equal to each other. So, so our points will be x equals plus minus r, y equals plus minus r, and z equals plus minus r root 2. for some r. Now, x squared plus y squared plus z squared equals 1 implies 4r squared is 1. So r is equal to 1/2. And thus x will be plus minus 1/2, y will be plus minus 1/2, and z will be plus minus root 2 over, so 1 over root 2. And so then if we list all of these out explicitly, I guess here are those points. The hottest points are going to be 1/2, 1/2, 1 over root 2. Actually, here we can put plus minus 1 over root 2, negative 1/2, negative 1/2, and then plus minus 1 over root 2. And the coldest points are 1/2, negative 1/2, and then plus minus 1 over root 2, and negative 1/2, 1/2, plus minus root 2. The temperature here being, so T is 20 over, so this is 20 over 8, so 5 over 2, and the coldest points are T equals negative 5 over 2 degrees Celsius.